Hi, thanks for joining us. My name's Devon Brown. I'm the Business Development Manager here at TaperedPlus. We have a northern office based in Stockton-on-Tees. This is where our purchasing and operations teams work out of. And then we have my colleague here, Nick Lane, who works from our Wolverhampton design office. Talk to you today about tapered insulation. Why do we need it? How do we do it? And of course, what are the choices available to you? Because there are a few. Nick will cover off the regulations and standards, and we'll also talk to you about what we can obviously offer during the course of this presentation also.
Firstly, we must ask why to fall. Why is it important that we ensure that water is effectively drained from a roof surface? And there's a couple of points on the screen, and I'm just going to quickly run through them. Algae, mould growth and ice in the winter months can create a slip hazard for those using the roof for maintenance, or if the occupants of the building use the roof area as part of their habitable space. Leaves and other sediment build-up create blockage on the roof if not drained away effectively. Green and brown spots on the roof can give a poor aesthetic appearance. A lot of waterproofing membranes have a unique selling point of reflecting solar rays. Bonding creates dark spots, which makes this less effective. A pierced membrane causes less internal damage if the water can run up and over the roof puncher rather than is sitting in a pool of water. Older problems are the most commonly reported problem with flat roofs reported to the NHBC. Deflections can occur under the weight of water because water is so heavy. And although many waterproofing membranes are tested to be in constant contact with water, problems such as the freeze-thaw and magnifying solar rays can have a big impact on the roof's lifespan. So there are many ways we can create a fall on the roof. The first being timber furrings. However, when we have more complex shapes, this can be more labour intensive. We have fall by design, or in other words, the use of metal purlings. We have falls using Screed. However, Devon will touch on the curing times that you must take into account. And with those first three examples, you must go over the top of them with a uniform insulation thickness to conform with Part L. So, tapered insulation provides both the drainage solution and the insulation layer all in one go.
Thanks, Nick. So yeah, as Nick said, there are typically three different types of ways of creating a fall on a roof. Creating timber furrings, the problem we have with that is we're down to human error. Furrings tend to be specified on a lot lesser of larger roofs than we do find them on the bigger roofs. You also have the screeding, and as Nick alluded to, the problem that you have with screeding is that it can take up to 1 month for every 25 millimetres of screed that's laid on a flat roof. As well as that, it can weigh a lot more than that of factory manufactured tapered insulation. There was an independent study that was done that determined that actually having a tapered insulation over a project of 500 metres, 1,000 metres, and I believe 1,500 metres as well, tapered insulation was more cost effective over the course of that whole project when you take into account the manual labour, the drying times, the cost of insulation and the like. So we do find that it's a lot more speedy process that's available as well for that. The screed is typically, tapered insulation is typically 3% the weight of screed as well. So again, going back to the section and the overall weight of that's on that substrate will be a lot less with tapered insulation than that of the other traditional methods.
We are asked by our customers to do budget prices next to our tapered schemes. However, in the past we have found this quite difficult. And the reason for this is because the cost variation of the schemes can differ massively depending on the roof size, the roof shape, maybe the outlet locations, and the overall taper scheme that's going to be put in place. We are still asked by many of our customers for the two examples shown on the slide, these being the most cost effective. However, the long flat gutters do not really go in line with industry guidance or British standards. We also have a big difference between the min and max thicknesses of taper schemes. All four examples are the same roof size and they still drain to the same outlet locations, however the min and max thicknesses differ massively dependent on the scheme. So therefore it's important that we try and get as much information as possible to provide the most accurate budget rate to the project.
There we go, thanks Nick again. So what are our insulation choices? So for the purpose of this presentation, we'll split them down into two different insulant types. We'll call one combustible and one non-combustible. The first ones that we'll again label as combustible for this presentation are as follows. So we do have a PIR, which is your most commonly used insulant on the market. Can be paired up with other types of insulant to offer different types of systems, but in the main, PIR system is the most common. These come in various different facer types or for different waterproof. Glass tissue faced insulation, which is typically used for your single ply membranes, your cold applied liquids and such, or self-adhesive with reinforced bituminous membranes also. Then could look at foil-faced insulation. This is typically mechanically fixed through the substrate and through the insulation, and would also typically be used on single-ply membranes. We then have a torch-on facer, which is used for hot works for reinforced bituminous membranes, where a heat gun flame torch will then be used. We then have an EPS. An EPS is an expanded polystyrene. It's used in an inverted and in a warm roof application typically. It's used as a cost saving versus of a PIR, and also used for places where we may need a little bit of a higher compressive strength also. We then go on to the EPS and PIR. This is a hybrid of the two. This is used mainly as a cost-saving option versus a standard PIR insulant. What we'll do is we'll use an EPS as the tapering board, and we'll have a better thermally performing PIR just as an overlay board that will allow it to bring it to the U values required. Will be slightly thicker, typically by 10 to 15 mil, but with the space available, certainly a worthwhile cost-saving option. We could also look at tissue-faced or PIR with vacuum insulated panels as well. These will cover a little bit more detail in a second, but these will be used where we have threshold issues of some sort. The last insulant we could look at would be an XPS, so similar to EPS in terms of it's a polystyrene, and again is used in warm and inverted roof applications, but used a lot more for when we need higher compressive strengths. So now for the other options available, we have our non-combustible. So the non-combustible insulant that we typically use is Rockwool, the world leader when it comes to non-combustible insulants, not only for facades, but also for flat roofing as well. Rockwool is very good and it serves a great purpose on flat roofs. It does have its slight limitations. The limitations occur really when it comes to the compressive strength of the material. If we have roofs that require maintenance, we need plant or access onto those, typically the compressive strength of Rockwool doesn't, although we'll hit industry requirements, we feel more comfortable, which is why we've introduced Rockdeck, which is where we can still offer a fully non-combustible system. It leads itself and has the compressive strength very similar to that of PIR. The difference being is it's a fully non-combustible solution. The third option we could access is what we call foam glass. Foam glass is a cellular glass that's not only non-combustible but also has extremely high compressive strength, but also comes at a serious inflation in terms of the cost in comparison to the Rockdeck. So again, non-combustible insulation drivers, although PIR is still very much used, we are finding more with government buildings that typically they tend to be specified with a non-combustible insulant now, really for safety more than anything else. In light of the tragedies that we had in 2018, we're finding that Rockwool and the Rockwool Hard Rock Multifix dual density board is being specified a lot more now, certainly in and around the London areas. It also future-proofs the building as well with extremely long product guarantees that are backed up by the declarations of performance. Now we have our vacuum insulated panels, so I alluded to it a little bit earlier. These are really good product where we have threshold constraints. So where you have certainly lends itself a lot more to refurbishment, where we have low thresholds for doors or windows that these can't be raised for one reason or another, but we still need to look to re-insulate these and bring them up to current building regulations. Where we're able to do this is by using a vacuum insulated panel paired up with typically a small overlay of a PIR. This allows us to achieve very good U values with minimal amounts of insulation. So very much a problem solver where space is an issue.
So we're just going to touch on some industry guidelines and British standards that affected flat roofing in the last couple of years. On the 30th of August 2019, approved document Part B was put into force and with it came some changes to how we look at flat roofing in the UK. The European classification system that ran alongside the national classification system for many years is now the first point reference for fire performance of roofs in the UK. And of the European classification system, the result being unrestricted and usable anywhere on the roof is B-Roof T4. B-Roof T4 is a fire test that tests fire penetration and spread if such a material like a burning tree branch was to fall on the roof area. Now, although many systems and insulation thicknesses should be tested to B-Roof T4, multiple trade bodies got together to understand what the worst OSB deck is when testing to B-Roof T4. So as long as OSB is used in the testing of B-Roof T4, if that system was to be placed on a concrete deck or metal deck, for example, these deck types will perform no worse. BS 8579-2020 was also introduced to try and do some clarification between a balcony and a terrace. In approved document Part B, A balcony is referred to as a specified attachment and therefore needs to be non-combustible. Many people still believe that a balcony is any area that is an external space used by the occupants of the building. However, the British Standard BS 8579-2020 tries to clarify this, in that a terrace is any area that has a heated space below it, as shown on the slide as number 5. This means a terrace area only needs to achieve B roof T4 rather than being non-combustible throughout. It's also important to note that approved document Part B does not give a different definition of what is the difference between a balcony and a terrace. In June last year, 2022, a revised Part L was introduced, and with it was just a simple tightening of U values for domestic extensions and refurbishment. For domestic new build, the U values we see are still on a sliding scale, and this is because there is room to play with the SAP calculation for the building. If the building's air tightness or window U values etc. are better, we might find that the U value on the roof needs to be slightly less. For non-domestic new builds, we still see U values on the sliding scale. However, rather than using SAP calculations, they use SBEM software. For non-domestic extensions and refurbishment, this did not change from the last Part L, and therefore it's likely that this was a missed opportunity by the government. When calculating U values, the methodology is set out in BSEN ISO 6946 Annex C. Before this, tapered insulation providers could simply work out the average thickness of a tapered insulation scheme and put it alongside the corresponding U value against it. However, this was deemed inaccurate. An example of this is on the slide. So on the left hand side, we have an example of two different insulation thicknesses, and when area weighting these two together, this only achieves a 0.23 U value. Where on the right hand side, we have the same average thickness of 130mm, however in a uniform layer, and this achieves a 0.18 U value. To give an explanation of the previous slide, this is because the millimetres of insulation needed compared to the U value achieved is not on a linear scale. The U value graph suggests that this is on a curve. So at the minimum point of a taper scheme, the less mil of insulation is required compared to the U value than that at the top of the insulation scheme. And putting the standard bore sizes aside, along with the flat insulation pieces, we also use valley and hip miters. These valley and hip miters differ in that a valley has more volume of insulation, and this is because a valley has two leading edges compared to the hip one. And therefore, we must ensure that we calculate these in accordance with the British Standard. The 2018 version of BS 6229 superseded that of the 2003, and at the end of this year, this is up for renewal. From a tapered insulation perspective, the main focal point in the 2018 BS 6229 was focusing on the minimum point of a 3.5 minimum U value at the minimum point of a tapered scheme. This is to ensure there is a backstop against condensation occurring within the tapered scheme. The more problematic change we found in 2018 was the introduction of 1 in 40 falls to give a finished falls of 1 in 80. This is because manufacturers of tapered insulation did not have 1 in 40 within their standard product range, and therefore we saw some commercial and logistical issues. The 1 in 40 was derived from more on-site trades such as timber furrings or Screed, where, as we know, tapered insulation is manufactured in a factory, and therefore the intolerances are slightly less. So at the end of 2023, we are likely to see an acceptance of 1 in 60 for tapered insulation schemes, and we are also likely to see some clarifications on the size and shapes of flat sump areas at the bottom of the tapered scheme, because this wasn't really clarified in the last BS 6229.
So what do we need from you? From a new build project, ideally a roof plan, whether that be an architectural drawing in CAD or DWG or just as a normal PDF. The required or the target U value, are we looking at a minimum thickness target, or are we looking at an overall weight or overall effective U value that we're targeting? The insulation type, or the facer type, is it going to be tissue? Or do we know that? If we don't, then do we know what waterproofing we're proposing? If so, we can make the judgment on what the recommended insulant would then be, and obviously the accompanying facer. Where are the current drainage positions? Where are the proposed drainage positions? Anything like that we've got will always aid us to make sure that we're recommending the most efficient way of that water drainage. So new build, very straightforward, all of the aforementioned points. If we're looking at a refurbishment project, then ultimately all we'd do is we'd go and conduct a free of charge roof survey. What this would involve is a full survey of the falls within the roof. We'd be checking for any potential backfalls if there were any. We'd also be looking at the current drainage, the current outlet positions. Can we increase these? Can we look to maybe add a couple more to make it even more efficient when it comes to the water drainage? All of these can be discussed on site or over the telephone, or we like to encourage virtual calls as well. If you have design issues or problematic details that you feel that we can help you overcome them, then absolutely we'd be more than happy to engage in that respect and certainly look to offer that where we can. What else can we offer? Certainly at the bottom there it says a full supply chain support. So we work with a member of partners in terms of waterproofing and obviously insulants also. So we can look after from the architect through to the tender to main contractor, through to tender to roofing contractor, through to the installation of the material on site and fully waterproofed also. Commercial and innovative tapered solutions. So again, I said earlier that we're not tied to a specific insulant, so we can look at the overall project and make a judgment based on its best solution for that. U-value calculations and condensation risk analysis. So these, again, something that we offer free of charge and as part of our standard service to enable you to understand or know that what you are specifying is going to be correct and no further problems will arise later on down the line when it comes to dew points and condensation, etc. Site surveys, so we've already discussed that previously. We have UK-wide national coverage in respect of surveyors, so can go anywhere pretty much needed with a little bit of notice. And I'd just like to thank you for watching, and we hope to engage with you soon.